even the issue of communication. How do you communicate with them if they are much more capable than we are? They might operate on a different level, a different.
Astronomers scanning the night sky with NASA's Atlas telescope in Chile first detected a faint anomaly on July 1st, 2025. A streak of light unlike any known comet or asteroid within our solar system. Initial observations revealed an object moving at over 100,000 miles per hour, its trajectory indicating an origin far beyond the heliopause, the boundary where solar winds give way to the interstellar medium. As data poured in from observatories worldwide, including the European Space Agency's telescopes, the object's hyperbolic orbit confirmed it as the third interstellar interloper ever identified, following Oumuamua and Borisov. Its size, estimated at several hundred meters across, suggested a mass potentially thousands of times greater than its predecessors, raising immediate questions about its composition and stability. Spectral analysis hinted at volatile ices, yet anomalies in its brightness fluctuations pointed to irregular rotations or outgassing events. Scientists scrambled to model its path, predicting a close approach to Mars before slingshotting around the Sun, but early simulations showed discrepancies that could not be easily explained by gravitational forces alone. The discovery ignited a global effort to track this celestial wanderer, with probes like those orbiting Mars repositioned for unprecedented views. Yet, as the object drew nearer, subtle deviations in its velocity hinted at forces beyond mere inertia, fueling speculation about what hidden mechanisms might be at play. But what if these deviations are not errors in calculation, but deliberate adjustments from an unknown intelligence guiding its course? Delving deeper into 3I Atlas's journey, researchers reconstructed its trajectory using advanced orbital mechanics, revealing a path that originated from the direction of the constellation Lyra, potentially ejected from a distant star system billions of years ago. Unlike typical comets bound by solar gravity, this object's eccentricity exceeded 1, confirming its interstellar status and implying it had wandered the galaxy for eons, possibly predating our own solar system. Data from the Gaia spacecraft's star catalog helped pinpoint possible source stars, but the vast distances, hundreds of light years, rendered precise origins elusive. As it traversed the Oort cloud, the object's speed remained anomalously constant, resisting the average motion of nearby stars, further isolating it as an outsider. These findings underscored the rarity of such visitors, estimated at 1 per decade. But 3I Atlas's pristine condition challenged models of long-term space weathering. Could this immaculate preservation indicate artificial construction, shielding it from the ravages of interstellar travel? Close-up observations as 3I Atlas approached Mars orbit provided the first detailed glimpses of its physical structure, courtesy of NASA's Mars Reconnaissance Orbiter and other assets. The object appeared elongated, with a rugged, uneven surface reminiscent of fractured ice. Yet its density estimates suggested a core far heavier than typical cometary material, possibly metallic or rocky inclusions. High-resolution images captured a growing coma, a hazy envelope of gas and dust, as solar heating triggered sublimation, but the tail's composition puzzled experts. Rich in water vapor, yet laced with unidentified molecular signatures not matching known solar system comets. Measurements pegged its diameter at around 400 meters, making it a potential interstellar monster, capable of catastrophic impacts if its path veered unpredictably. Rotational periods, derived from light curve variations, indicated a tumbling motion, but periodic stabilizations hinted at internal dynamics. Spectroscopic data revealed abundances of heavy water and exotic isotopes, suggesting formation in a star system with different nucleosynthetic history. Dust particle analysis from trailing debris showed crystalline structures atypical for natural formation, prompting debates on whether these were forged in extreme environments or engineered. The object's albedo, or reflectivity, fluctuated anomalously, as if sections were absorbing or emitting energy selectively. These revelations painted a picture of a hybrid entity, blending cometary fragility with unyielding resilience. What hidden mechanisms within its core could explain these fluctuations? And might they betray a non-natural origin? Recommended word count, 400 to 550 words. Chapter 4. The Erupting Enigma. As 3I Atlas neared its perihelion, dramatic changes unfolded. The object began expelling vast quantities of water vapor, equivalent to a fire hose on full blast, far exceeding risks, recalling the disintegration of previous comets. Yet 3I Atlas maintained integrity despite the violence of its emissions. Infrared observations revealed temperature spikes localized to specific regions, as if energy was being channeled deliberately. These behaviors rewrote assumptions about interstellar chemistry, indicating that alien star systems might harbor water-rich environments vastly different from our own. The eruptions also scattered dust clouds that interfered with some observations, adding layers of mystery to its study. Scientists pondered if this activity was a natural response or a triggered event, perhaps in reaction to our solar system's unique conditions. But if these eruptions are not random, what signal or stimulus might be provoking them from within? In laboratories and observatories across the globe, teams dissected the data on 3I Atlas, applying rigorous models to demystify its anomalies. Mainstream astronomers attributed its peculiarities to natural processes, the water outgassing as sublimation of exotic ices formed under different stellar conditions, the mass discrepancies to porous structures filled with low-density materials. Comparative studies with Oumuamua and Borisov highlighted evolutionary differences, suggesting 3I Atlas originated from a young, volatile, rich system. Simulations using supercomputers replicated its path, accounting for gravitational assists from distant stars, and explained velocity tweaks as minor outgassing thrusts. Skeptics dismissed alien theories as sensationalism, pointing to Occam's razor, the simplest explanation being a comet, albeit an extraordinary one. Peer-reviewed papers emphasized its cometary nucleus, with tail composition aligning broadly with interstellar medium expectations. Yet, even in these analyses, gaps persisted. Unexplained isotopic ratios and the object's resistance to tidal forces near Mars. International collaborations proposed future missions, like flyby probes, to gather in situ data, but time constraints limited options. The scientific community remained divided on minor points, such as the role of dark matter interactions in its acceleration, but consensus leaned toward natural origins. What if the data hides patterns that science has yet to decode, pointing to something beyond nature's design? Recommendo's word count, 500 to 650 words. Civilization. Viral theories posited it as a mothership, deploying probes or scanning for life, with its water eruptions masking communication bursts. Historical precedents, like unexplained radio signals from past interstellar objects, were revisited, though debunked by most. Proponents argued its mass and stability suggest hollow interiors or advanced materials, resistant to cosmic hazards. While NASA officially classifies it as natural, leaked reports of anomalous transmissions during Mars flyby intensified debates. These ideas, though controversial, underscore humanity's quest for cosmic company, challenging paradigms of isolation in the universe. Investigations into potential technosignatures continue, scanning for non-random patterns in its behavior. Firefox, could these whispers be the first echoes of contact, or merely echoes of our own fears? Recent observations as 3I Atlas skimmed Mars's orbit unveiled startling developments. Mars-based instruments detected faint, intermittent signals emanating from the object, coinciding with intensified outgassing. These bursts, analyzed by NASA's Deep Space Network, exhibited structured modulations not easily attributable to natural plasma interactions. Imagery from orbiters showed surface features evolving, craters or vents appearing to open and close rhythmically, as if responding to environmental cues. The proximity allowed for unprecedented resolution, revealing metallic glints amid the icy exterior, prompting re-evaluations of its composition. Atmospheric interactions with Mars's thin air produced unexpected auroral effects, hinting at electromagnetic fields stronger than predicted. Scientists noted trajectory refinements post-Mars encounter, suggesting gravitational anomalies or deliberate maneuvers. These findings, released in October 2025, shocked the community, with some interpreting the signals as potential artifacts of alien technology. Collaborative data from Chinese and European Mars missions corroborated the anomalies, ruling out instrumental errors. The shocking truth emerged as a blend of natural wonder and lingering enigma, rewriting textbooks on interstellar visitors. Shells, but as it hurtles toward the sun, what final secrets will the intensifying heat force it to reveal? As 3I Atlas continues its inexorable journey sunward, the implications for humanity loom large, with unanswered questions, internal energies, and the nature of its emissions. If natural, it offers a window into alien worlds. If artificial, it signals we are not alone. Astronomers warn of similar visitors ahead, each potentially more revealing or threatening. The investigation into 3I/Atlas underscores the fragility of our knowledge, reminding us that the universe harbors secrets beyond current comprehension. What other interstellar monsters lurk in the darkness, waiting to invade our skies?